you have the eye of the viewer. You have your visual rays, how you're looking at the object. And then you have the object that you're viewing. Okay, with a perspective, a 1 point anyway, 2 point is different. When you set up a 1 point, you can set it up one of two ways. You can set it up where your object is sitting on your plane of projection. That makes the front view of your object, or at least part of the front view, true shape and true size. So if I'm looking at, again, this object here, and this is my top view, and this edge here represents my plane of projection. So this is my plane of projection. I have my object sitting on my plane of projection. Again, so that if I were to take a piece of paper and lay it on top of an object, I can trace that object at a 1-to-1 scale, because the piece of paper is directly on top of it. So that makes this front view of this object, at least this portion of the front view, 1-to-1. So this is the true, on that plane, this is the true size, and we're just going to have an offset like that. That's the true size of that front view. That gives you a reference for your other distances. Now, the further the object gets away from you, the smaller it appears. So when I look at the front view of an object, the further it gets away, the smaller it appears. And with a perspective, it vanishes at a point, and this point sits on the horizon. So the object will get smaller and smaller the further it gets back, until at some point it vanishes and you can't see it anymore. The point at which it vanishes is your vanishing point on a 1 point, and it sits on the horizon. So if the vanishing point changes or the horizon changes, it will change what the perspective looks like. So we had you lay it out based on the values given, so everybody's perspective should look the same. So we arbitrarily, here we're just going to pick a vanishing point, and that vanishing point sits on the horizon. So this is my picture plane, this is my horizon, and that's my vanishing point. All my lines that's going to show depth, where they intersect here in this view, goes to the vanishing point. Now I could just approximate this like a sketch, like we do over here. I could just say, okay, I want to sketch this, and just approximate where we're going to put our vanishing point. All of this goes to our vanishing point. We approximate the depth of this object so that it looks like that. That shape, stair shape. Okay, so the vanishing point is normally found by the station point. The station point represents the eye of the viewer. So the viewer is looking at some object, and in this case here, the eye of the viewer can be anywhere on the drawing in the space. But the eye of the viewer typically is set up first And then the vanishing point is located directly above or below the eye of the viewer based on the horizon. So the horizon can move up and down. Station point goes where the horizon is at. It sits on the horizon, but it's located in line with the vanishing point moves. It's located in line with the station point. So if I change my station point over here, my vanishing point has to sit here now, and then my lines that go back to show the depth converge at the vanishing point. So this is my station point. This represents the eye of the viewer. So all of these are variables that can change. So all my corners on my object, except the front face, because I don't need that, because I know the true size and shape of that. All the distances, how far back does this go, I have to get it from my top view. So all the corners or intersection points converge at my station point. So I draw lines here to get the depth of my feature. So now so we have lines here to show depth going back to our vanishing point, and we have to get the depth of wherever, how far, what's that distance from here to here, and we do that by taking lines from my station point here, or lines from my object going to our station point, where those lines cross the picture plane. Now sometimes students have it crossing the horizon. Where the line here that shows, that goes from my feature here to my station point, cross the picture plane, I bring that line straight down, and where it hits this line here, going to my vanishing point, transfers the depth of this feature into that view. So I know that this line from here to here is right there. It goes right there. My parallel lines that were horizontal lines here remain horizontal. So that would just be a horizontal line. If I take this and go to there, and if I bring that straight down, it works when you're doing it accurately. When you're not doing it accurately, it's off. But this point here should intersect that point also. So whether I draw this here straight down to locate that point, or just take him over horizontally to where it hits this line, it should be at the same point. So my horizontal dimensions locate, so that locates that vertical line. And then that gives me that. Since that hits there and this has to be horizontal, that should take me to there. If I do this and bring it down, it should match up. And then that gives me my vertical edge there. And that's, in this case, my perspective of that drawing. If I have a feature, let's say back here, that's not sitting on the picture plane. So I have a cutout here. If I have some portion of the object sitting on the picture plane, then I can draw this object true size relative to what it would be on this front surface. So the width of this on this front surface would be that width right there. So I could take this back, so that's where it would sit if it's on the front surface. So I can take this back and draw this line here. Draw this here, and to get, and as when you draw this, it shows you what's happening here. as my object gets further away, it gets smaller and smaller. Okay, so now what I do is, so to locate this point on this line, again, I just take this point to my station point here, where it crosses my picture plane. I bring it straight down. And where it intersects this point locates this corner right here. And so this is a horizontal line, so that's that right there. To do my back edge, since I know those two are going to be horizontal, I can just go here, where it crosses my picture plane again. I bring him straight down. It locates the other edge there. This is a horizontal line. Again, it might look distorted because I'm sketching it, but that's where that box is sitting on that surface. And then this here is a straight line there because you can see it a little bit inside the box. So anything that's not sitting on a picture plane in a one point, wherever it's sitting at, I could project the edges of it down to where it hits. That tells me if it was sitting here, this would be the true distance of it. So I take those back to my corner. It shows me my lines that converge, so you can see that my box is going to get smaller and smaller, because when it's sitting back here, it's going to be smaller than sitting up here because it's getting further away. So then again, I just bring my corners here down where they cross the picture plane. I locate the corner on that line there. Since he's horizontal here, I just draw a horizontal line. It should intersect right there and be correct. And then I get the back corner, and then I got him done there.
All right, now what do you do when you're starting with a blank sheet of paper?
You take the measurements that I have given you. Now on this sheet here, if you notice, the measurements are coming from the edge of your paper. So you take that 11 by 17 sheet of paper, measure from the edges of the paper, not the title block. And when you get done, it should be sitting on there. If you measure from the title block, part of your drawing is going to go off the sheet.
So when we're starting with a blank sheet of paper, we establish where the vanishing point is. Okay, I got that.
Well, you follow the measurements first.
Okay.
You follow the measurements, locate all the components.
Do we need to sketch on the front and top views?
This is using your instruments. Make it accurate. This is not a sketch.
Well, I mean, when we're doing the drawing.
Well, you need to draw the top because you need to get information from the top view.
Okay, so we need to
So
draw
this
the
should
top
be
view.
a dark and thick view, just like this here.
But
This here should be light initially.
But the front view is for reference and measurements. We don't actually draw that on.
No, you're going to draw it because
Well, we're going to
your
draw it in
perspective.
perspective, not the flat on, straight on view.
But you need the flat on straight on view initially, lightly done, so
Okay.
you can get your correct outline and the correct measurements. Because this becomes part of your perspective, as you can see.
So when we start with blank sheet of paper, we're going to do we're basically going to put the front view and the top view on the sheet, but the front view lightly, top view darkly.
Right.
And then use those views to establish where the perspective is going to be.
Right, because your perspective is going to be part of that front view when you get done. So here's the person looking at the object, and this is what they see.
Okay. I just wanted to establish that what was actually supposed to be on the end product.
Yeah, your end product should have everything up here. You should have a line representing your picture plane, a line representing your horizon labeled, all of that labeled. All of this stays on your drawing. All your lines here that are lightly done. When this gets done, then you darken in the shape of the object. So when this is finished, you darken it in and leave all your light construction lines on there so I can see what you've done.
So the picture plane and the horizontal need to be marked dark and thick?
No, it can be thin, dark and thin.
Dark. Okay.
Dark, thin, picture plane, dark, thin, horizon.
And when we're done, the original front would be drawn over.
Right. It'll be.
Because the front's not going to match perfectly, of course.
The what?
Because the front view and perspective is not going to match the straight-on view that we have on the sheet.
Well, the part that sits on the picture plane will match perfectly. Anything off of that won't match up, but you need to, just like I said, if I have this here and I'm trying to determine the size of this, I at least have to draw a reference line straight down so that I know in this view here it's this big. And then I got to take it back, and then as it goes back it gets smaller and smaller. So that's why initially the features should be on your front plane for true size. But then, like on that one that you have where this thing does this, and let's say that, now it doesn't do that. I'll just show part of it. Part of it, and you have, you have this right here that sits out here. Well, part of, okay, so you should draw this true size. Because at some point, you're gonna take this back to a vanishing point, and then this is going to go back to your vanishing point. You're going to get this feature here where, that's too thick. Let me take it back. You're going to say this, let's say that this is your thickness of this feature here. Well, this also locates the back portion of this feature right here. So, bring it forward for me. Okay. So this also locates this feature here that's sitting on the back there. But I initially start off on the picture plane where this would be the true size, and then back here it will be a little bit smaller. Well, I also have the hole here sitting true size on the picture right here on the orthographic view there. But when I take the quadrant back, and when I take these back, and then when I locate the center of this and come down, I can take these back to where they would hit on the quadrant of that, and then use those points as a reference to construct another circle, and this circle should be smaller than that one, because it's further away.
And anything that's actually sitting against the picture plane would be true size?
True size.
Okay.
So we're showing the transparent view of the hole on the other side? As it goes, yeah, well, you're showing the hole.
The opposite side.
On the opposite side of the front hole, we're showing the back hole transparent? So
Here?
Yes.
Now, this is a reference to get to this point. When you finish this, this will be darkened in, because that becomes part of your perspective, and this will be darkened in. This will be light. You can erase it or you can leave it. It's better to leave it if you draw it initially lightly. And then the part that now should be darkened in, you go ahead and darken in those portions. And the light portions that you use as a reference to get back to here, you can keep them light. Just leave them on there. That way I can come here and I can check if I see something that doesn't look right, I can check. Because sometimes students will, instead of where it crosses a picture plane coming down, because on one of these drawings, maybe you didn't get the drawing, but on one of these drawings, the horizon is pretty close to the picture plane. And they come off the horizon and the object is longer than what it should be.
Yeah.
But this lets me track how you did it and everything. To see where you went wrong if you did something
So
wrong.
in perspective, there'd be no hidden lines,
No hidden lines.
visible lines and center lines, and that's it.
Don't need center lines. I need a center line initially here so I can track back to locate. And yeah, back here I'll need a light, but make it light, because you shouldn't have center lines on pictorial drawings typically. So since you're starting with an orthographic view, you can make all of this like a light center line only so that you can locate your points on your quadrant, and then take a circle template of that size and create your circle.
Oh, I think I got it. I don't know about everybody else. Yeah, makes sense.
Now, if you take your architectural classes, you're gonna pick up additional perspective drawing. You're gonna wind up doing at least a 2-point perspective, maybe more. See, so this is an introduction. It's introduction to technical drawing. You learn how to do obliques. You learn how to do ISOs. You know, just simple project. You learn how to look at what a perspective is, a 1-point, 2-point, and how to do at least a 1-point perspective. As you go through the program, you wind up doing those same things, but you get to more complicated features. So you might wind up doing a 2-point perspective of a house. It's a little bit more complicated than this. Of course, your 1-point is your simplest. So you build on this. So whatever you learn in here, don't discard it once you leave here like you'll never use that information again. You will. Because what'll happen is you'll get into another class, and then I'll say, remember in the intro we did some isometrics. And then the glaze come over your eyes. I said, okay, anyway, we did isometrics in intro. Now we're going to show you how to do isometrics on AutoCAD. It has some features that'll help you, but still you have to know how to do the ISO. It's not going to do it for you. You're still drawing, but you're drawing on a computer. If you lay the lines out wrong, they're going to be wrong. It just does what you tell it to do, whether it's right or wrong. So everything you've done in this class, you're going to wind up applying it when you get into the AutoCAD class or any of the CAD classes that you might take. You're going to do orthographic projection. You're going to do perspective. You're going to do obliques. You're going to do ISO. You're going to do sectional drawings and other stuff that you hadn't learned yet. So, don't do a brain dump after you leave here. If you want to continue on in the program, you got to retain all this information. That's why we have you do a portfolio. In every class, you do a portfolio. Hopefully, you can use some of that information and refer back to if you need to. It also builds, if you're going to go into the university and become an architect, you're building your portfolio as you go. So by the time you leave here, because you got to have a portfolio for any architectural program to get into it. They want to see your work. Some of your work might consist of drawings. Some of your work will be pictures of models and stuff that you build. But it's going to be a portfolio. In regular drafting, where the guys aren't going to the university, they do portfolios too. So here I got a student here, he's ready to graduate this semester, and so he says, the company that I applied for want to see some of my drawings. I said, well, you did all of those notebooks for each class, right? Yeah, but I don't have them all. So that's part of your portfolio, man. That's why you did them. So you can go in there, and you can reprint them and stuff. You can go in there and selectively choose, okay, I want this, this, this. This shows my skills in doing complex isometrics. Go into this notebook where I did some complex orthographic drawings. Go into this and pull them all out and say, okay, I'll use this, 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 and this. Give them a little, that's my portfolio. Put a cover letter in there, resume in there, and so forth. You know, because they don't know what you can do. Now, they still might give you a test. But I've had plenty of students that take a notebook down to, and they look at your drawings and stuff, and they see the complexity of some of your work, and they say, okay. And then, so if they do give you a test, they expect you to be just as good as your notebook shows you are. on the computer, you know. You knock it out, and then they hire you up there, see? It works.
Yeah.
You got to have something. You don't have any experience. You're coming out of the program. They don't know what you can do. They give you a test. At least a portfolio shows a variety of different drawings that you've done, the range at which you can draw. You know, you're not just limited to mechanical drawings. If you do mechanical, you can do architectural and so forth, civil. So in the CAD courses, you get a variety of projects. Everybody does architectural, mechanical, civil, electrical, whatever, so that they can see the wide range of that you can do on the computer, wide range of drawings. Works out. You got to become more marketable. If you just limit yourself to a certain area, then that cuts down on the job prospects. So you broaden your horizon, and there's more jobs out there that you're likely to be suited for, and you can apply for. See, if I had limited myself to civil, which is what I really wanted to do when I left here, because I graduated from this program as well. And when I left here in 80, got my first job, I couldn't get a job doing civil. Nobody wanted me. So I wound up doing mechanical. And it was really a good job because I was the only drafter. First time they ever hired a drafter. And they didn't know what a drafter's supposed to do anyway. But all they knew is I was supposed to be able to draw. And the engineer said you have to be able to draw anything anybody gave you from any department because you're the only drafter. And I said, okay. I did mechanical drawings, electrical drawings, piping drawings, did architectural drawings, I did technical illustration drawings. I did a little bit of everything because they have different departments, they need different things done. And so I got a broad knowledge of different types of drafting. And that really helped me out when I came back to the college to teach because I had to be able to teach every drafting course offered in this program. And everything that was offered was some of the stuff that I did in industry. I did electrical, I did technical illustration, I did the mechanical, I did the architecture, I did structural, I did a little bit of everything. So when I got back here to teach, I was well-rounded and I could teach every course. My specialty is mechanical because that's where most of my work came from in geometric dimension and tolerancing, but you had to do it all. A drafter draws, the engineer that he said a drafter should be able to draw anything you give him. Okay, that's what you do, you draw. That's the engineer that I worked for. That was his ideal of a drafter. You could draw anything that I give you, right? I said, yes, sir.
No problem.
Piece of cake.
I didn't say no problem now. I said, yes, sir. I could get it done. It might be a problem initially.
Yeah.
I don't know what I'm doing up front here because this was something new to me, but
Okay.
I'll get it done.
I'm glad we all in the same boat there.
It worked out pretty well. So, anything somebody gives you, you should be able to draw. So start drawing.
All right. Thank you for the pep talk.
Yeah.
I got your test done.